This is another episode of 3D Printing News Unpeeled. And today we're going to look at a couple of news items for you. And one is Creality. So Creality has come up with a new 3D scanner. This is the CR-Scan Ferret. It costs around $349. They've got an app for it. They've got software for it that hopes to make it work better. They've got an ASIC chip on it that is supposed to improve the image processing. There's a visual tracking element there. Um, it captures both color and texture and maps it automatically to the point cloud. And the company says that it's optimized it to work in sunlight, which is often a big problem with handheld scanning and scanning in general. It's got two different scanning modes. One is meant for bigger objects, and the other one is a more highly accurate for smaller object kind of scanning mode. And that highly accurate mode has 0.1 millimeter accuracy at resolution 0.16 millimeters. And yeah, it's difficult to I don't know what to think of this. So the first off, Shining 3D is shown with this Einscan printer in the $1,000 to $3,000 space, and a little bit above that now. That they have a really credible offering that's brought down the cost of 3D scanning, has made scanning much more accessible for orthopedics and for artists and for all sorts of people. There are more advanced scanners like Artec Eva and stuff, 2030K and above, these kind of things. And there are lots of different scanners for lots of different different applications, like for traffic accidents or scanners for buildings, all this kind of stuff. But no one's been able to really make a consumer level or even like an inexpensive professional level scanner. There have been some attempts around the $2,000 price range, but this is like $349, and around this price range, we see point, we see failures, and there have been a ton of failures in 3D printed scanning and scanning startups, and this space has been incredibly toxic, incredibly difficult to do because it's a computational challenge, it's a software challenge, and it's a hardware challenge, and all of that, it makes this a very difficult thing. To give you an example, I often do these roundups or these kind of like market snapshots where we look at all the players in the market. If I do that for desktop 3D printing, well, I just go through the companies. Some have left the market, some have new printers, some have new offerings, right? But if I do a 3D scanning, like in a report or like a market research thing, often a ton of the companies just disappeared or completely been bought over, completely changed, all this kind of thing. It's a very brutal space to be active in. What I love about this is Creality seems to be wanting to do scanning not as a product expansion, not as a way to make money necessarily on the scanning, but as a way to increase the 3D printing business, as a way to saying, look, if we make scanning inexpensive and easy, more people will make more geometries and more printers, and that'll help us as a company develop. And I think what we should be paying attention to is the fact that Creality is trying to develop a software and an app-based ecosystem. So an app that handles files. They have their own Thingiverse. They've got more slicing software. They're really going the software route. So that's going to be a battleground, I think, for these low to medium price 3D printers as well. I hope they pull this off. I hope everybody's going to be able to, in a couple of years, buy a really reliable $300 scanner. I think that would be amazing. I'd love to use that myself. I'd love to see what people would do with that professionally if we could do that. And I'd love to see what just average creators who now are not into 3D printing could do in order to enable them to 3D print more. So love this, but still, yeah, it's a battleground. The scanning thing is going to be a really uphill struggle for them to make this value proposition work. So we'll see. Okay, the next news item is the University of Arizona, where apparently you can walk in the sunshine amongst the cactuses. They have gotten a $1.2 million grant for hypersonics. This is from the Office of Naval Research, specifically the Defense University Research Instrumentation Program. And Andrew Westman and Sammy Tin are the two professors at University of Arizona that are going to be administering this. And this is, essentially, this is tied to hypersonics, but it's an equipment-based program. So what the guys are going to try and do is to get research equipment to develop alloys specifically for hypersonics. This is sorely needed. Hypersonics are under a lot of pressure, a lot of heat. They were basically self-destructing themselves as they go at Mach 5 or Mach 10. And none of the materials made nowadays can withstand these kind of intense pressures, intense heat. So we need new types of steels. We need new types of high entropy alloys. We need new types of intermetallics. We need new types of oxygen dispersion materials, new ceramics. So this kind of thing is sorely needed. What they're going to do is they're going to buy a gas atomizer, I'm guessing a relatively small one, LPBF system, X-ray diffractometer, and a vacuum furnace for this, which I hope they're like going to go on Craigslist if that's a thing, or eBay or something, because this is a bit of tight budget for all those things. But okay. Um, and they're going to use this to develop new alloys. I think this is a wonderful thing. Using 3D printers, we can develop alloys, right? We can develop alloys for even really specific tasks, really, really small batch. And we need these really specific alloys in order to further 3D printing for hypersonics and aviation generally. So I think this is a great development. And good for the University of Arizona, because they, Wildcats, as they're called, have their very own hypersonic center. So that's kind of that's going to get a boost out of this. And the University in Wichita, on the other hand, is going to get a slightly bigger boost. The National Institute of Aviation Research at Wichita State University has gotten $100 million for a 5-year R&D project by the U.S. for the U.S. Army. Now, this is the Modernization of Integrated Technology for Ground Systems Award, which is the Materials Division of Advanced Manufacturing. That is part of DEVCOM and the Ground Vehicle Systems Center, which is at Detroit Arsenal in Warren, Michigan. And the notable thing here is not only, okay, this is a huge, huge project, right? Also, it's a longer term project. It's not some SBIR kind of thing. This is like a longer term thing. And what it is doing is parts qualification for LPBF and DED, right? And that's already notable that they're saying, look, we're going to go to parts qualification, materials qualification, machine qualification. We're going to let you as a university do the heavy lifting and trying to figure out what the right settings are to make us this stuff, let us produce this stuff to spec. So that's one thing. That's really big, right? Big deal. Going forward, though, what's a bigger deal is that this is for ground vehicles. Like, we all know there's a huge business case for 3D printing for new space, right? For anything that moves generally. But hey, if it moves fast, if it needs to go far, there's a great business case. Satellites, rockets, space vehicles generally, missiles, aircraft, all that stuff. We know if we save mass, if we integrate components, or if we save weight, or we reduce mass, or at the same time we reduce mass, we integrate components. We have fewer parts. We make more conformal. We make more optimized structures. We all know for these kind of fast-moving, high-moving objects that really, really makes a big difference. Now, but look at a tank on the other hand, and we know that we can save weight on a tank, but so far the costs have just not worked out. The only thing that's really happening on tanks in 3D printing is there's some armor applications, and there's also some shell applications. And there's also, in certain cases, turbines. The turbines in the engines of these tanks can be refurbished through 3D printing as well. But 3D printing's tank spare parts has been beyond our means at the moment, because these parts are massive. They're really, really, they weigh a lot. They use a lot of material. And generally, yeah, it just hasn't worked out. So this is really notable because it really would extend 3D printing into the vehicle space, grounder vehicles. So we're talking really large components, and we're also talking really massive numbers. What is also notable about this is that whereas a airbase, right, is usually quite in a safe place, it might actually be back in the United States of America, or it could be at one location in a country, a contested country, or it could be in a near ally, near peer kind of country, or it could be in a surrounding country or something like this. It's usually not very close to the front line. Meanwhile, if you were talking about vehicle maintenance and repair, vehicle operations, printing parts for vehicles, then we want to be as close to the front line or as close to danger as possible as we can get it. So we're talking about a much more distributed capability potentially as well. So more massive parts at lower cost, at higher volumes than we're accustomed to, closer to the front line. So we're going to look at like some really different technologies. So low cost DED and powder bed fusion systems, especially DED type technologies where we take a wire. Or we could use a blown powder as well, but that of course is going to be a bit more dangerous. More difficult to store as well. So probably a wire-based technologies would really have an edge here, because it's easier to store, it's even lower cost. So these kind of technologies could really be doing a lot of work here. And then I think the bigger opportunity going forward is not only that MRO just replacing parts, but also improving them. So imagine you find out that certain tanks that you have a certain really specific limitation. The visibility is limited. Well, you could maybe change that visibility by entering into service a new component that could increase the visibility for the crew, for example. And we can do that quite quickly and quite inexpensively, relatively inexpensively, using 3D printing. So upgrading the kit that's in the battlefield to suit that battlefield and the evolving conditions there, I think would be very powerful. But anyway, this is huge. Now, there is something we need to realize as well. Like, we are being dragged kicking and screaming into the military, right? And in the United States of America, research generally is already very military kind of leaning, especially if we're talking about the bleeding edge, blue sky type of really new stuff. But we risk getting kind of swallowed up as an industry by this U.S. defense spending. I mean, think about this. This is $100 million grant. Um, I would be surprised if the oh, sorry, I just sneezed there. Sorry. So it's live because I had to sneeze. Terribly sorry about that. But so but anyway, so it's 100 million grant for one part of the United States Army, right? Which is one part of the U.S. military, and it's not everything in the U.S. military. It's not everything in the Army. This is one particular part for one particular command looking at ground vehicles, and it's already $100 million grant, right, for new technologies in this space. I'd be surprised if the Netherlands, the country I'm from, or Spain, the country where I live in and reside in at the moment, I'd be surprised if these countries are spending $100 million on 3D printing as a whole, right? On research, right? So we're really we have to realize that we are going to be a lot of our industry is going to be militarized if we like it or not. And you could say it's a wonderful thing. You could say that that we should take these contracts to um, or you can see no ethical issues with this at all. But even if you do, there is an issue if there's going to be one big paymaster for our industry, and that's going to be the U.S. military, because we're going to adopt more of their ways of thinking, and we're going to focus on their materials. We're going to focus on not necessarily the best ones. We're going to focus on developing the things that they want. So I think this is something that we really need to think about. Anyway, so this is the end of our show today. My name is Joris Peels. This is another edition of 3D Printing News Unpeeled. I hope you enjoyed it. This was valuable to you in some way, and see you again the next time.